A typical scenario during model fitting is that one wants to optimize a model to fit one set of data and then re-optimize it to fit a second set of data where only a handful of the parameters are allowed to be different between the two different optimizations. So one can iteratively do this by optimizing to one model, then holding fixed all those parameters that should not vary and re-optimizing to the second data set. Or it's more useful to simultaneously optimize the model to both datasets and simply specify which variables are allowed to vary between the two different optimizations. In Kinetic Model Builder, this is done by specifying mutant variables. If we go up to the Info tab in the model window, we have a list of variables. In this particular case, we have one variable, k-on, which is the on rate for our model, the value of 1. And we also have an option to specify mutant variables. Mutant variables, we can have any number of them. They are matched to variables by name, and the name has to match perfectly case sensitive. So in this case, the variable k-on has a mutant value of 10 and a regular value of 1. If we want to actually use this mutant parameter, we need to make sure it's turned on. And so now our drug binding rate, which is set to the variable k-on, will be 1 for the wild type case and 10 in the mutant case. And the term mutant is simply in reference to the biological sciences, where it's typically the case that one has a model of a particular protein, and one also has a mutant of that protein with slightly altered behavior. And we'd like to fit the model to both, with only maybe a small number of parameters in the model being different between the two different fits. So in this case, we'll only allow our binding rate to change between our wild type and mutant models. And if we now run a simulation, Kinetic Model Builder will simulate this entire series of drug pulses. This protocol is the same protocol used in the tutorial on optimizing a model. And it will repeat this entire family of drug pulses with k-on replaced by its mutant variable. So let's go ahead and run that. All right, so in blue we have the response, the open state probability in response to a series of drug pulses when k-on has a value of 1. And in red we have our mutant simulation, which is the same series of drug pulses, the response in the open state when k-on has a value of 10. And if we look down in the lower plot with the summary, we don't see the mutant simulation. And when that occurs, just you want to make sure that you are actually set to show the mutant simulation. So here's our wild type and mutant summary. We can to optimize the model to data for both our wild type and our mutant actual experimental data. We can go up into the Info tab, go to our reference data. Here I've actually already preloaded 2 data sets. Let's just turn them on. They are both referring to the probability in the open state. However, if we scroll over to the right here, one of them is marked as being associated with the mutant simulation and the other the wild type simulation. So now let's resimulate to see that data. There we go. So now we have our wild type data set in blue with its reference data and mutant in red, and we can look at them one at a time. There's just our wild type. There's just the mutant, and we'll put them both back on. Okay, so now let's go ahead and change our parameters for k-on so that they don't match the data very well, and then we'll re-optimize the model for both data sets simultaneously. So let's just set the values to 5, so from 1 to 5, and for the mutant variable, we'll just set that to 5 as well. So both of them are now different from their original values, which were 1 and 10, which are what the reference data is in reference to. Okay, so now to optimize the model for both data sets simultaneously, we'd simply click Fit. Before doing that, we want to make sure that our variable is not fixed, and also that our mutant variable is not fixed and it's active. Now we just click Fit. And there we have it. It's re-optimized the model for the wild type and the mutant, and we can go and look at those values. The wild type is returned to 1, and the mutant is very close to its original value of 10. That's it for simultaneously optimizing two different data sets where only a small handful of parameters are allowed to vary between the two different optimizations. Thank you very much.